Yes, so now I come here in this video to calculate the frequency and wavelength of radiation emitted by electron when it jumps from higher orbit to lower orbit. So frequency and wavelength of radiations. Emitted transition from one energy state to another, having lengthy, but I am continuously working here on Bohr theory. We know from Bohr theory that energy of electron in nth orbit En equal to Z square E4m minus upon 8 epsilon 0 square n square h square. Here student, write 2 times, 3 times, 4 times by your brain. You will learn it. Very important atomic theory. Actually, Bohr theory is the window to the atomic theory. Though this theory could explain only spectrum of hydrogen atom, or it could explain the few aspects of H atom, but it was the basic and entry to understand the atom. Now, energy of electrons in N1 and N2 orbits. N1 and 2 are the different orbits, say 1, 2. So En1, or here N1 less than N2. इनके N नंबर N2 से छोटा है, and then number of orbit. तो En1 minus Z square E4m upon 8 epsilon 0 square N1 square into H square. En2 minus Z square E4m upon 8 epsilon 0 square and 2 square H square. So these are the values of energy of electron. If electron present here in N1 orbit, this is the value of energy. If electron go to N2 orbit, and then it is this. Now, according to third postulate, if electron jumps or jumps from and 2 and 1 orbit. Dear student, I am telling if electron is present in this orbit, the energy is this. If I am to the energy this. It is known as the electron present here and here, both at place. It may be here or here. So, if electron jump from an to another orbit, then from third postulate, energy emitted energy of radiation emitted. Electron lose energy when jump from higher to lower in the form of electromagnetic radiation. Is given by H nu is equal to E and 2 minus E and 1. This minus this, it will become plus. So here H nu is equal to this minus this minus the plus. So Z square E4 M upon 8 epsilon 0 H square bracket 1 upon N1 square minus 1 upon N2 square. Nu or nu is equal to Z square E4M upon 8 epsilon 0 square H cube. This H here into 1 upon N1 square minus N2 square. This is the expression for frequency of radiation emitted. This frequency, and that radiation may be in the form of ultraviolet radiation, may be in the form of visible light, depending upon value of N1 and N2. Depending upon value of N1 and N2. We know lambda is equal to C upon nu, or nu is equal to C upon lambda. Nu is equal to C upon lambda. So C upon lambda is equal to Z square E4M upon 8 epsilon 0 square H cube 1 upon N1 square minus 1 upon N2 square. One upon lambda is equal to E4M upon 8 epsilon 0 square CH cube into Z square. I deliberately wrote it like this because of some reason I will tell you. E4M 8 pi epsilon 0 CH cube is a constant value. which we write as R Z square 1 upon N1 square minus 1 upon N2 square, where R is equal to E4M upon 8 epsilon 0 square CH3. Here R this R is called Rydberg constant. This expression is similar to R in Rydberg. I will tell you something about this. The equation 1 upon lambda R Z square 1 upon N1 square minus 1 upon is similar to Bohr's empirical formula. One upon lambda equal to R 1 upon 2 square minus 1 upon N square. For H atom Z is 1. Actually, Bohr explained the wavelength present in the spectrum of H atom. I have shown you. If we see the spectrum of hydrogen atom, we find spectral lines like this. I have shown you. So Bohr series here has wavelength varying from 6,500 656 nanometer to 364 nanometer. He obtained these values putting R equal to 1.09 10 to the power 7, and this formula was derived on the result of experiments he obtained. Here is 2. Putting n equal to 3, 4, 5, 6, he got the wavelength of light or radiation present in this series, Bohr series called. He could explain only these wavelengths, not all. So Bohr got satisfaction on his theory that this formula is resembling with Bohr's formula. If we put R, value of R is here. What is R there? E4M upon 8 epsilon 0 square CH3. If we put the values of all these constants, we get R equal to 1.03. We get value, 1.03 10 to the power 7. Yes, 10 to the power 7 unit per meter. वो यहाँ से आ जाएगी, ये नंबर, ये भी नंबर, 1 per meter. Per meter is the unit of Rydberg constant. So directly we can explain now, or Bohr explained the wavelength present in hydrogen spectrum using this formula and putting all these values. Now using this formula, using this equation, Bohr obtained wavelengths of radiations present in hydrogen spectrum. Hydrogen spectrum means actually when we take hydrogen in a tube and pass electric current through it, then some radiations are emitted. If those radiations pass through a prism, so we find a spectrum of radiation, means wavelength by distribution. I have shown this diagram. So these wavelengths by light is emitted by sun, by all sources of light here, electric bulb, LED, fluorescent tube. So the same way we can obtain. So the first series was Lyman series. Lyman series. है ना? Bohr, suppose it is equation बन गया. Bohr used n1 equal to 1, n2 equal to 2, 3, 4, 5 and so on. So wavelength of radiation of Lyman series 1 upon lambda equal to 1.03 10 to the power 7, 1 upon 1 square minus 1 upon n square, यानी कि n2 square 2, 3, 4. Putting n1 equal to 2, he got longest wavelength. N equal to 1, n1 equal to 1 और n2 equal to 2. तो हम रखते हैं n1 equal to 2, 1 upon lambda equal to 1.03 10 to the power 7 और 1 minus 1 by 4. So it becomes 3 by 4, and therefore lambda is equal to 1 upon 1.03 10 to the power 7 or into 3 by 4, 4 by 3 meter. It is equal to 4 upon 903 10 to the power minus 7 meter. Actually, here, first orbit, second orbit, third orbit, so when electron jump from here, so it gives the longest wavelength, and this longest wavelength has wavelength 3365 nanometer, close to, 3 by 4, 4 by 3. 4/3. So 1 yeah. 1.11 10 to the power minus 7 into 3 angstrom. Yes, it is our longest wavelength nearly. Shortest wavelength of Lyman series. Shortest wavelength that 1/lambda is equal to 1.03 7 into n11 n to infinity, or lambda is equal to 1/1.03, which comes out to be 91 nanometer. Yes, 91 shortest wavelength. And all these wavelengths got verified and lie in ultraviolet region. Ultraviolet radiation for